The world of mathematics is full of wonders. Speak your thought, walk your talk, and make these wonders a reality. Good day, grade 11 students. Welcome to the second episode of Pre-Calculus for Quarter 1. This is Sir Jeff, your guide as we journey to an exciting and amazing world of pre-calculus. And to all grade 11 students, just relax, enjoy, and appreciate the beauty of mathematics. For this episode, we will be learning about the equation of a circle.
At the end of the lesson, we will be able to explain the properties of a circle. Write the equation of a circle in standard form given its center and radius. Write the standard form of a circle in general form. And find the equation of a circle defined by various conditions.
Before we begin our discussion, let's start with a short activity and see if you are ready for our lesson.
Answer the following questions. Use a piece of paper to write the letter of your answer. Number 1. What is the equation of the circle in standard form, where the center is located at the point of origin with radius r? The correct answer is Number 2. What is the standard form of the equation of a circle, if the center is at point 6, -11, and the length of diameter is 10 units? The correct answer is Number 3. The circle passes through the point 1, 2, and is concentric with another circle whose equation is x squared plus y squared minus 12x plus 4y plus 15 equals 0. What is the equation of the circle? The correct answer is Number 4. What is the equation of a circle whose center is located at 7, 7, and is tangent to x-axis? The correct answer is and number 5. The center of the circle is located at -8, -3, and tangent to y-axis. What is the equation of the circle? The correct answer is
How many correct answers did you get? If you got a perfect score, that's great. But if not, don't worry, because I will be here to guide you as you explore and discover the lessons in this episode.
From the previous episode, we discussed the different types of conic section. We also discussed how each conic are formed through the intersection of a plane and double right circular cones. This time, let us discuss the first type of conic section. Circle.
What is a circle? A circle is a set of all coplanar points such that the distance from a fixed point is constant. The fixed point is called the center of a circle. And the constant distance from the center is called the radius of a circle.
The equation of a circle is identified when it is graphed on a Cartesian plane. From this illustration, a circle is graphed on a Cartesian plane where the center is at the point of origin, 0, 0. We can also see that radius, r, is the distance from the center to a random point of the circle, represented by the coordinates, x, y. If the circle is graphed in this manner, the equation is x squared plus y squared equals r squared, which is called the standard form. On the other hand, if the center of the circle is not located at the point of origin, we use the coordinates h, k as the coordinates of the center, instead of 0, 0. The radius r is the distance from the center to a random point of the circle, x, y. If the circle is graphed in this manner, where the center is not located at the point of origin, the equation is the quantity x minus h squared plus the quantity y minus k squared equals r squared. Take note that this equation is also in standard form. There are two different standard forms of a circle that I mentioned a while ago. The first one is x squared plus y squared equals r squared, where the center is located at the point of origin, 0, 0, and the length of the radius is r units. The second standard form has an equation, the quantity x minus h squared plus the quantity y minus k squared equals r squared, where the center is not at the point of origin, but instead, it is located at point h, k, while radius is also in r units. Take note that these two standard forms of the equation of a circle are also known as the center radius form. Meaning, you can write the equation of a circle by just using the coordinates of its center and the length of its radius. Let's have some Given the coordinates of the center and the length of the radius, determine the standard form of the equation of a circle. Number 1, the coordinates of the center is at 0, 0, and the radius is 5 units. And number 2, the coordinates of the center is at -2, 7, while the radius is 4 units. For problem number 1, since the coordinates of the center are located at the point of origin or 0, 0, we will use the standard equation, x squared plus y squared equals r squared. Using this equation, we simply substitute the value of radius r, which is 5, to the equation. Then, it will become x squared plus y squared equals 5 squared. Therefore, the equation of the circle is x squared plus y squared equals 25. To picture out what our circle looks like, here is the graph of our circle on the Cartesian plane. The equation, x squared plus y squared equals 25, has center plotted on the point of origin or 0, 0, with radius of length, 5 units. For the second problem, the center has coordinates, -2, 7, which is not located at the point of origin. Therefore, we will use the standard equation, the quantity x minus h squared, plus the quantity y minus k squared equals r squared. Aside from variable r, that stands for the radius, this equation also involves variables, h and k, that represent the coordinates of the circle. And from the given, h is equal to -2, k is equal to 7, and r is equal to 4. By substituting these values to the standard equation, we get the quantity x minus -2 squared, plus the quantity y minus 7 squared equals 4 squared. Next, we evaluate the terms. And it will become the quantity x plus 2 squared, plus the quantity y minus 7 squared equals 16, because the negative of -2 is +2, and the square of 4 is 16. And this is the equation of the circle. Now, let's take a look at the graph of our circle plotted on the Cartesian plane. The equation has center at -2, 7, and the radius has length of 4 units. Now, take note of this. When we used -2 as the value of h, we came up to this term, negative of -2, which eventually became +2. I have a simple tip for you. If the center of a circle is not located at the point of origin, just like this, we can substitute the values of h and k to the equation by simply changing their signs. For -2, it will become +2. And for +7, it will become -7. Using this shortcut, we can easily find the final answer, without actually doing this. But this doesn't apply to the radius, because the value of radius is always positive. And when you square the radius, it always gives us a positive answer. But, what if one of these coordinates is 0? For example, variable h is 0, or variable k is 0. Of course, you don't have to substitute the value of h or k to the equation if it is 0. I hope you remember that simple but effective tip when you find the standard form of the equation of a circle. The standard form of the equation of a circle can also be written in another form. That is, x squared plus y squared plus dx plus ey plus f equals 0, where d is equal to -2h, e is equal to -2k, and f is equal to h squared plus k squared minus r squared. This form of equation is what we call the general form. Let's have an example. Transform the equation, the quantity x plus 3 squared plus the quantity y minus 4 squared equals 36 into its general form. We can transform this equation into its general form by solving the coefficients d, e, and f. Since the standard form is called as the center radius form, the values of variables h, k, and r squared can be taken from this equation. At first, the signs of h and k were changed when they were substituted in this equation. Therefore, we simply take them back into their original signs. So for positive 3, it should be negative 3 when used as variable h. Negative 4 here is originally positive 4 when used as variable k. And finally, 36 stands for r squared of the standard equation. Take note. Changing the sign only applies for variables h and k, and not for radius r. Let us solve for coefficients d, e, and f, using these formulas that were given a while ago. To find the value of coefficient d, we will use the formula d equals negative 2h. By substituting the value of h, which is negative 3, it will become negative 2 times negative 3. And the answer is. Next is to solve coefficient e using the formula negative 2k. Substitute the value of k, which is 4, and it will become negative 2 times 4. And that is equal to. Last, we have to solve for the value of coefficient f, using the given formula. Substituting the values of h, k, and r squared, we get negative 3 squared plus 4 squared minus 36. The square of negative 3 is 9, and the square of 4 is 16, then copy minus 36. Last step, we evaluate 9 plus 16 minus 36, and the value of f is. We can write the general form of the circle by substituting these three values to this equation. The equation will become x squared plus y squared plus 6 times x plus negative 8 times y plus negative 11 equals 0. If we simplify this, the final answer is x squared plus y squared plus 6x minus 8y minus 11 equals 0. This is the general form of the equation of a circle.
We can easily write any equation of a circle if its center and radius are given. But the equation of a circle can also be found from different conditions without directly stating its center and radius from the given. Let us solve these examples.
Find the equation of a circle described by the following conditions. Number 1, the circle is concentric with a smaller circle, the quantity x minus 1 square, plus the quantity y minus 2 square equals 1 and passes through the point 5, 6. Number 2, the center is at point 0, 7 and passes through the point 8, 3. Number 3, the endpoints of the diameter are located at negative 2, 5, and 9, 4. And number 4, the circle is tangent to x-axis with center at negative 5, negative 10. Problem number 1 states that the circle that we are looking for is concentric with this equation. When we say that circles are concentric, it means that they have the same center. Since the given equation here is written in standard form, we can easily identify its center. And that is 1, 2, which is taken from the values of h and k in the equation. It was also stated that the circle we are looking for passes through the point 5, 6. Let's take a look at the graph below. We can see that the center 1, 2 of the given smaller circle is also the center of the unknown larger circle. From this figure, the unknown circle is the red one that passes through the point 5, 6. Now, let us use the standard equation of the circle, and substitute the given values of h and k that represents the center, as well as x and y that represents the random point 5, 6. By substituting these values, we can solve for the value of r squared. 5 minus 1 is 4, and 6 minus 2 is also 4. Squaring 4 gives us 16. And 16 plus 16 is equal to 32. The value of r squared is 32. Now that we have the coordinates of the center, as well as the radius in terms of r squared, just substitute these values to the standard form of the equation of a circle. Therefore, the larger circle that we are looking for has an equation of the quantity x minus 1 squared plus the quantity y minus 2 squared equals 32. Now, let us proceed to problem number 2. This is similar to the first problem. The center, h, k, is given, as well as the random point, x, y, where the circle passes through. So, we only need to solve for the value of r squared. By graphing, our circle should look like this. The center is plotted at the coordinates 0, 7, and the circle passes through the point 8, 3. Using the standard equation of the circle, substitute the given values of h and k from the coordinates of the center, as well as x and y from the random point where the circle passes through. By doing this, we can solve for the value of r squared. 8 minus 0 is 8, and 3 minus 7 is negative 4. Squaring 8 gives us 64, and the square of negative 4 is 16. Finally, 64 plus 16 is equal to 80. And that is the value of r squared. With the given coordinates of the center, and the value of r squared, therefore, the equation of the circle is the quantity x minus 0 squared plus the quantity y minus 7 squared equals 80. Or simply, x squared plus the quantity y minus 7 squared equals 80, because the value of h is 0. For the third problem, it states that the endpoints of the diameter of a circle are -2, 5, and 9, 4. We need to find the center along the diameter, which is the midpoint of these two coordinates. To do this, we will use the midpoint formula. This formula needs to have the values of coordinates of the first endpoint, given as x sub 1, y sub 1. And the coordinates of the second endpoint, x sub 2, y sub 2. From the given, our first point is -2, 5, and the second point is 9, 4. Substituting these values to the midpoint formula, we'll get the first coordinate of the center as the sum of two x's, divided by 2. And that is -2 plus 9 over 2. And for the second coordinate, it is the sum of two y's. And that is 5 plus 4 over 2. Simplifying these fractions gives us -2 plus 9, that's 7 over 2, and 5 plus 4, which is 9 over 2. And these are the coordinates of the center. By graphing the circle, we can now solve for r squared, using the center, h, k, and choose from one of the endpoints of diameter as random point, x, y. To solve the value of r squared, we can follow the same process of the previous two problems, by substituting the values of h, k, x, and y. As I have mentioned before, you may choose any of these 2 points for the random point, x, y, since they are both part of the circle. In this example, we will use the point, 9, 4. Substituting these values to the standard equation, we'll get. Next, we evaluate this equation. 9 minus 7 halves will become 11 halves, and 4 minus 9 halves will become -1 half, by combining a whole number and a fraction. Next, we square these fractions. 11 over 2 square is equal to 121 over 4, and -1 half square is equal to 1/4. Remember that squaring a number always results to a positive number. Then, we add them. Since these fractions have the same denominator, we simply add their numerator, and copy the common denominator. Hence, 121 over 4, plus 1/4, is equal to 122 over 4. And finally, we can simplify this fraction into its lowest term, and that is 61 over 2. This is the value of r squared. Going back to our standard equation, let us use the center, 7 halves, 9 halves, and the computed r squared. Therefore, the equation of the circle is the quantity x minus 7 over 2 square, plus the quantity y minus 9 over 2 square, equals 61 over 2. Finally, let's solve the last problem in our example. The center is given with coordinates, -5, -10. It also states that the circle is tangent to the x-axis of the Cartesian plane. Let's take a look at the graph. As mentioned, the circle is tangent to the x-axis. Meaning, the circle touches the x-axis at one point only. We can observe here that the length of the radius can be measured as the distance from the x-axis, going to the center of the circle. From this figure, that is 10 units downward, or -10. And since -10 is represented by variable k of the center, h, k. Therefore, the radius, r, can be solved as the absolute value of k. Substituting the value of k, we have, r, is equal to the absolute value of -10. And we all know that the absolute value of any number is always positive. Therefore, r is equal to 10, or r square equals 100, because we will use r square to the standard equation. With center at -5, -10, and the value of r square, which is equal to 100, the equation of the circle can be found now using the standard equation. Substituting the values of h and k of the center, and the value of r square, the equation will be the quantity x plus 5 square, plus the quantity y plus 10 square, equals 100. If you encounter any problem about writing the equation of a circle that involves tangent to x or y axis, here are the tips for you that will save your time. If the circle is tangent to x-axis only, the length of its radius is equal to the absolute value of k. This concept was applied to the last problem that we solved. And, if the circle is tangent to y-axis only, the length of its radius is equal to the absolute value of h. But, what if the circle is tangent to both x and y axes? What is the length of its radius? Well, you may choose the absolute value of h or the absolute value of k. It doesn't matter, because if the circle is tangent to both axes, the absolute value of h and the absolute value of k are always the same. Solve the following problems involving equation of a circle. Number 1. The native basket crafted in Puerto Princesa city has circular base with a standard equation, the quantity x minus 10 squared plus the quantity y plus 8 squared equals 15. Write its equation in general form. The correct answer is. We can find this general form of the equation by solving the values of d, e, and f, and then substitute these values to the general form of the circle. And number 2, Peter is sitting at the edge of the circular fountain located in front of Puerto Princesa City Coliseum. Assuming that the center of the fountain is at point C, -2, -3, of the Cartesian plane, and Peter is located at point -5, 5, find the equation of the circular fountain. The correct answer is. In this problem, the given are the coordinates of the center, and a random point where the circle passes through. First, you need to solve the value of radius r, or r square, by substituting h, k, x, and y to the standard equation. From there, you can now find the equation of the circle using the coordinates of the center, and the value of radius. On the screen is an illustration of a Ferris wheel, one of the rides at Puerto Princesa City Baywalk during events, like the yearly Christmas fanfare. Given the coordinates of the center and the length of its diameter, find the equation of the circle in standard form. For this problem, the coordinates of the center are already given at 2, 6. We only need to look for the value of the radius, in order to identify its standard equation. Here, the diameter of the Ferris wheel is given with a measurement of 14 meters. Taking half of it will give us the value of the radius, which is 7 meters.
We are now done explaining and applying all the information we learned from our topic. Now, let's summarize our lesson by answering another activity.
Fill in the blanks. Write the missing part to complete the following sentences. Circle is one of the conic sections, formed from the intersection of a plane and cone. It is a closed curve that has a fixed point inside, called blank of the circle. The distance between this fixed point and any point at the edge of the circle is called blank. The standard form of the equation of a circle, where its center is located at the point of origin of Cartesian plane, is written as blank. If the center of the circle is not located at the point of origin, its equation is written as blank. The equation above can also be called as the blank form, because it has the coordinates of the center at blank and a radius denoted by variable blank. Another form of equation of a circle is called the general form, which is written as blank. What are the formulas used to find the values of coefficients d, e, and f of the general form x squared plus y squared plus dx plus ey plus f equals 0?
Before we end our episode, let's have a short quiz to measure if you attained our learning objectives. Go get your paper and pen and answer the following.
Read each question carefully and write the letter of the correct answer on your paper. You may pause this video while answering the problems. Good luck, students! For your assignment, solve this problem and submit it to your subject teacher on the scheduled date.
Congratulations, grade 11 students! You have completed all the activities from the lesson in this episode. Hopefully, you have learned a lot and put all your acquired learnings into practice by exploring this beautiful subject, pre-calculus. Once again, I am Sir Jeff. See you on more exciting episodes, only here on Puerto Princesa Dream TV.